Hi everybody, welcome to this again the aerodynamics class. We are continuing the potential flow only. In the potential flow, we have seen the psi value and phi value of uniform flow. Now we are discussing about some new things today. And today we are going to talk about the two-dimensional flow of uniform flow. What is the meaning behind the uniform flow? Uniform flow can not only the uniform. Okay, two-dimensional flow. Mainly, I want to emphasize on the two-dimensional flow. The two-dimensional flow cannot on it. We have talked only about the uniform flow, but apart from the uniform flow, also there is source and sink flow is also a potential flow, and also the point vertex. So today we are going to talk something about that. I've given some definitions of it. So uniform flow, when we call it the uniform flow, the flow is defined as a uniform flow when the flow field, the velocity, and the other hydrodynamic parameters do not change. So then we can call this the uniform flow. And same way it is a source or sink flow. Source and sink almost characters are same, like the plus and minus. The same way source and sink. What is the when we call it a source flow or a sink flow? Let us we try to understand the definition first. Then we will go to the next. Source flow is defined as the two-dimensional flow containing from a point called source and moving outward radially when not radically, it is outward radially on a plane in a uniform rate. Then we can say that is the source. In case all the flow come and merge in the towards the same point, then we call it is a sink. In case it is going out from the one point radially, then we can call it a source. And point vertex. In a vertex, we can see it keep on, the verticity will be there in the same point. So we'll say that a free or potential vertex is the flow with particular path around the central point such that the velocity distribution is still satisfies the irrotational condition. Because the irrotational conditions and all the things we can say, and that it is a no viscosity, we say that is also a potential flow, and so we are considering point vertex also. So with this uniform flow already we have completed the psi and phi value, and let us talk about the source and sink today. That is the what we talked about, that only pictorially I am trying to explain. The source flow is defined as a two-dimensional flow containing from a point called source. That means from source and moving out radially on a uniform rate. Uniform rate it is going out, not all of a sudden it is coming down and the flow rate and it is increasing. Increasing and decreasing is not there. That means it is uniform rate. If it comes down, we can call it either our source and sink source and sink definitions. So pictorially let us see the source flow. Source flow, you can see that from a particular point all the flows are going out radially, and sink means all are coming in the towards the point O. Okay, you take this is the point O. Okay, in that point O. So what is the psi and phi? It will be in this case how much it is going out. These are the all the psi values. All are the psi values are here. Okay, and we have studied that psi and phi they interact, or they not interact, they cross each other at orthogonally. So that means when it will be orthogonal, in case I'll draw a concentric circles, then there at any point you can see it, both psi and phi values are obviously they are intersecting each other orthogonal. So this is at the center, it with the phi 0. Slowly you assume that more orthogonal or concentric circles if you draw, they are the phi 1, phi 2, phi 3. It will be like this. Same thing is, and there you take a sink. Sink means the same thing, but it is in the opposite directions, right? Towards the point O. So let us see about this one. We have seen what is the two-dimensional flow and source or sink. Why I am saying or? Because they are not the and, means it may be different, or maybe or what are the things you use, but they are the both are same. Only that their directions are changing, but strength are same. Strength we generally define as M. We say M is the our strength. M is the strength. So if you consider any point in any direction, that we are going to talk it now. So in that case, source or sink, how it will be? A source or a sink, we can take its strength is, in case it is a source, we will take it is the M. In case it is a sink, we will take it is a minus M. For any given point, okay, which fluid is appearing or disappearing at a uniform rate of that source or sink, at what is its unit, it will be m square, that means m square per second. Since it is two-dimensional, this is m square per second. If it is three-dimensional, m cube per second. So let us talk about the stream function psi of a source. What is the stream function psi? Stream function psi of a source. We are trying to understand this one, or if you do it, let us consider a source file with the origin O. Okay, let us consider a point P. Let us consider a point P somewhere else, and that point I have given both coordinate systems. I have given it here, r and theta in polar coordinate systems. You can consider, or you can consider in a x and y its coordinate system in Cartesian coordinate systems. So we will consider that what is the flow across, what is the, if we will consider this point, okay, and then how much is the flow across OQ, that means OQ, how much is the flow across, plus how much flow is going out across the QP, right, on the QP in this one. So then it will give us that totally how much, there depends on the theta value, right? So there is R and theta. Where is the position R? In case it is here, somewhere else, we will see it on that. So we will see it. That means we are talking about the velocity across the OQ into OQ. That the velocity across the OQ plus OQ. Velocity across the QP into the QP. Here the velocity into the distance. Velocity into the distance. Okay. So if we look at how much velocity across the OQ is there in case in this is a coordinate system, if we will take it, this coordinate system. So OQ and velocity is there, though there is a distance Q, but velocity is across this 0. So 0 into OQ, if you multiply, it comes as a result 0. And what is the velocity across QP? Velocity across QP is equal to how much is the strength of our source M by 2 pi r into the r theta. Okay, into the r theta. If we do it, let me remove this. Sorry. And now we will say the psi value is equal to how much we got, sir? And here you can see this r and this r will get cancelled, right? Let me do it again. This one, that means this R and this R will get cancelled. So we'll get sorry m theta by 2 pi. So psi value is equal to m theta by 2 pi. That is in polar coordinate system. But I have written here polar coordinate system as well as the Cartesian coordinate system. In Cartesian coordinate systems, what we can write it? We can see it Cartesian coordinate systems. We know that in case if you will draw a diagram like this, so what we will get? The u component, v component. This will be the theta angle, and this is the resultant. This direction velocity is going, so that is the resultant of it. So theta is nothing but equal to tan inverse of y by x. Then this theta value, if we can now substitute in this equation, what we will get it? We will get the psi value is equal to m by 2 pi tan inverse of y by x. Okay, so we got, and this is in the Cartesian coordinate system. Very, very frequently hereafter we will use these two. So let us see about, now we talked about the only stream function. What about the velocity potentials? Velocity potentials, we are going to talk about the velocity potentials phi of a source. If we will take the velocity potential phi of a source, the same diagram let us consider, and we know it, the velocity everywhere in the field is radial, right? That is the velocity at any point. P is equal to r theta. Now we are considering again from the polar coordinate we are starting, and it is given by q is equal to how much? That is the normal velocity component plus tangential components. If you will square root it, and then we will get the resultant of it. That we have seen it, we know it. So q is nothing but equal to q normal, and qt will be my equal to 0, right? It should not be qt, it should be the subscript of qt. Qt is equal to 0. Then if we will integrate around totally OQP, O, Q and P, if we will integrate, then we will get the total amount. So let us look into that. From that, if you will do is equal to phi into qp into q cos theta b ds. This one already we know it, and q on the OQ, from the OQ, and q to p, again q to p, if we will do it, we will integrate q cos beta ds, and that means if q cos beta ds is nothing but our, that is normal component into the distance, the radial one, and plus the qt into r d theta. Okay, so with this, if we will do it, qn into dr plus this component will vanish because there is a no flow. Okay, no tangential flow, so whole term will become the 0. Okay, so let us say then qn is equal to how much we are getting? Qn is equal to m by 2 pi r, right? That we know it. That is nothing but qn is equal to m by 2 pi r. Okay, this is the way. And if from that, if we will take it, what we will get out of it? Phi is equal to, that means this is equal to phi, right? So phi is equal to, it is the integration of, that means if we will take the integration from the origin to the considered point, that in origin, let it be the r0, and this is the point r. If we will integrate, what we will get? We will get the integration of r from the upper limit r to the lower limit r naught, m by 2 pi r dr. If we will integrate, we know it, m is constant, 2 and pi is also constant. 1 by r dr. Integration of it, how much we get? We get generally, this is the constant term, right? This is the total is a constant term. So log of r by r naught. Generally we write ln, that is the natural logarithmic, or we can write the log to the base e. Okay, so we got the phi value like this. So we got the now psi and phi value in the source and sink. When we talk about the source, it is positive. You remember that in case it is sink, it is negative. We have to add the negative sign to it. Okay, so in case you assume, this is the beauty of it, in case if r naught in the radial is the equipotential, phi is equal to 0, somebody may ask you this. Okay, so you should be careful. Okay, again, thank you very much for the class and for this video. How it is, I'm expecting the feedback to improve, and you can reach me in my WhatsApp number 9500145037, or in my personal mail ID prasanta.mohanta at the rate of gmail.com, or official mail ID m.prasantakumar at IARE.ac.in. But I prefer that you should reach me always. Most of the time I prefer my official mail ID. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.